My name is Andrew and I'm from Home Group 2 for Digital Signal Processing. What is fast Fourier transform that we're studying? The fast Fourier transform FFT is an efficient algorithm used to compute discrete Fourier transform, which is DFT. It converts a signal from a time domain into a frequency domain. So why is FFT so important? It's because a time domain signal shows how a signal changes over time, while a frequency domain signal shows what frequencies are present and their strength. The purpose of FFT in signal processing is that it is used for identification for frequency component in signals and analyze it in terms of amplitude and phase, detecting noise and interference, and designing and apply this digital filter while extracting features for control. And this is some example, the equation. FFT exists due to the limitation of DFT as it requires n-square complex multiplication and addition for an n-point signal. The computation time increases quadratically with signal length and becomes impractical for large data sets, high sampling rate signals, and real-time or embedded system. And this impacts the signal processing as it requires high power consumption, increased processing latency, and limit the real-time frequency analysis.
We have two ways to convert the time domain signal into the frequency domain signal. One is DFT, another one is FFT. So here we are showing the comparison between the DFT and the FFT. You can see the DFT we need 64 operations to done for a n equal to 8. But for the FFT we only need 24 operations to complete the conversion. The working principle of the FFT, you can see the upper formula is the general formula of the DFT, and then we convert it into a polar form. Then you can see the real part is a cosine function, and then the imaginary part is the sine function. So from the basic formula of the FFT, we need to add a trigger factor is a phase corrector that invert the magnitude. One is positive and another one is negative. Then the evens part will remain, then we can get the FFT conversion.
The butterfly structure is the basic computational unit of the FFT algorithm. It operates on two input samples, usually one even index and one odd index sample. The odd sample is first multiplied by a twiddle factor, and then simple addition and subtraction are performed to generate two output values. This butterfly operation is repeated across multiple stages in a radix 2 FFT. By reusing intermediate results and reducing redundant calculation, the butterfly structure allows FFT to reduce computational complexity from order of n squared to order of n log n. FFT is widely used in many real-world signal processing applications. In audio and speech processing, FFT is applied for noise reduction, audio equalization, and speech analysis. In communication system, FFT is a key component in OFDM, which is used in Wi-Fi and 4G or 5G technologies. FFT is also used in biomedical engineering, such as ECG and EEG analysis, to study frequency characteristics of biological signals. In addition, FFT is also applied in image processing for image compression and filtering.
Hi, my name is Joy Chuan. Now I want to expand the tutorial question 8 to calculate the DTFT magnitude response with the given input signal xn at omega equals 0 to 5 pi. So we can assume that the input signal is starting from 0, and we can expand the TTFT formula into x omega form. And inside that, s more than j omega can transfer into cos omega minus j sine omega. And after substitute the omega value, we can get the 1 plus j minus 1 plus 2 to calculate the magnitude. We need to do the Pythagoras theorem, and finally we can get the 1.0824. Next tutorial question B, repeat question A using f1 DFT, means the capital N goes to A. Find the k value for omega equals 0.25 pi with the given DFT formula. To find the k value, we need to use the omega equals to 2 pi k over n. Substitute the value, the k equals to 1, and substitute all the value back to the DFT formula. We can get the formula same as the question A, so directly can get the 1.0824 for magnitude response. Thank you. Question C, compute the form 5 FFT SK with the given input signal using the butterfly diagram, then compute the complexity. First, we need to do the bit reversal and categorize to top and bottom. So the first top using the S0 and X2 with the value of 1, and the bottom using the S1 and S3 with the value of -1. After calculate the sum and difference, we can get the top equals to 2, 0, and the bottom equals to -2, 0. So for Twitter factor for 4-point FFT, the W0 equals to 1, and the W1 equals to -j. By substituting the formula, the final FFT result SK equals to 0040, and for the n equals to 4, the complexity formula n log to n, substitute the n value, we can get the complexity equals to n.
Hi, so now I'm going to explain the three key factors that make the radix 2 FFT a fast computations. There is three main factors I have listed out, which is divide and conquer approach, another is reusing the intermediate results, and the last one is periodicity of Twinder factors. So following by the next questions, FFT is a computational efficiency method to calculate the FTs. Discuss briefly how this is achieved through the radix 2 FFT algorithms, and specify one disadvantage that radix 2 FFT might have versus DFT. So the radix 2 FFT split the data into two chunks, so which is processed separately and then combines. This reduces the number of calculations from O n to the power of 2 to O n log n, so making it much quicker and it's also used butterfly operations to mix the data efficiently without needs for extra memory. However, one downside is that the length of the data must be a power of 2. I think that's all from us. Thank you.